Hey, astronomy folks, how you doing here today? Mr. Bowsy, I'll be your teacher for this virtual lesson. Okay, we are going to talk about the formation of a red giant, right? Why do stars become giant and red? Okay, so that's what we're going to do today. Now, what I've done, and this is a little unfair because I have natural abilities, and not all people have. I have these abilities. I have already perfectly recreated a picture of a star and the core of a star. So here it is. I'm going to just jump right to it. All right, boom. Holy crap, it's so beautiful. Okay, so this is the core of a star. This is the outer edge of the star. And you'll notice two perfect circles. You don't have to stress about getting perfect circles on your notes. It's okay if they're not. Okay, but here's what happens, and this is a key piece that you need to understand right here. Okay, right now in the sun, literally millions of nuclear bombs are going off every single second in the core of the sun. Now, when I say literally, I mean figuratively. Work with me here, people. All right, but that much energy is being generated in the core every single moment, every single second in the core of the sun. So the question is, why doesn't the core of the sun just blow up like a nuclear bomb, right? And the answer is gravity. Gravity stops that from happening. Right now, in the core of the sun, hydrogen is fusing into helium, right? Which is producing tremendous amounts of energy, right? The energy is causing the gases in ionized gas in the core to expand. Think back to chemistry, right? Increase the temperature, the volume wants to increase, right? So it's going to try to rise. So there is this balance right now where in the core of the sun, the energy being produced from fusion is being equalized, countered, neutralized by an equal pressure on the outside from gravity. This is what we call hydrostatic equilibrium. All right. Hydrostatic equilibrium basically means the energy generated from fusion in the core of the sun is trying to cause the core to expand. It's balanced out by the gravity trying to contract the core so it stays the same size. This is what we want in a star. We want the star's core to stay the same size because that keeps the star stable for as long as it can. But eventually, 5 billion years from now, the sun will run out of hydrogen. When that happens, we lose this energy in the core. All we have is gravity. So what does gravity do? It squishes the core down to an even smaller size, right? Gravity pushes it and pushes it and pushes it. And again, think back to chemistry, folks. If you increase the pressure, what you're going to do is you're going to increase the temperature. It increases the temperature tenfold, right? It gets so much hotter, right? That eventually what happens is helium will ignite. And it will ultimately, through two steps, form carbon. That's going to be what it generates. Okay. So the gravity compresses the core. Temperature goes up, gets hot, gets really hot. It gets so hot that helium, even though helium has two protons, the two protons in one helium atom, the two protons in another helium atom, they're under so much pressure and they're moving so fast that when they hit each other, they stick and they get the formation of a larger atom. That's what fusion is, right? And it produces energy. And then we have a new hydrostatic equilibrium. The sun will be in equilibrium as a red giant for about 2 billion years, right? Which is pretty handy dandy. All right. But eventually it'll run out of helium too. And that's a story for another time. But let's talk about what happens on the exterior of the star. Okay. The core in a red giant gets smaller and hotter. Core gets smaller and hotter, way hotter, significantly hotter. Well, the outside layers of the gases, because of all of this tremendous heat, right? What happens to it? Well, these outside layers, right? If you give gas more energy, the volume expands. Thinking back to our gas laws, this is just ionized gas, plasma. It begins to expand. So the core gets smaller and hotter, but the surface gets bigger and cooler. When stars get cooler, they turn a reddish color. The sun will expand so greatly, the volume will increase in size so much so that the orbit of Mercury, the orbit of Venus, the orbit of Earth, and maybe even up to the orbit of Mars will be inside the radius of the star. Earth's orbit will be inside the red giant version of our sun. Whew, it's going to be hot. It's going to be hot. Yeah, maybe a little too hot. There you go, folks. That's how red giants work. Short, sweet. Thanks for listening here today. Be good, stay safe, stay healthy, and cheers, mate. Cheers.